The diels-alder reaction. The diels-alder reaction is the conjugate addition of an alkene to a diene. So the simplest example is the reaction of ethene to 1,3-butadiene. So 1,3-butadiene is our diene, ethene is our alkene, and the alkene and the diels-alder reaction is referred to as the dienophile. It loves dienes, yes? Dienophile. Okay, so in the diels-alder reaction, this is what happens. That their second bond on your alkene, on your double bond, attacks carbon 1 on your diene, and then that bond goes, you form a double bond between carbons 2 and 3 on your diene, and that their double bond between carbons 3 and 4 attacks the other carbon on your alkene. And in diels-alder reactions, you always form a cyclohexene structure. All right, so just for reference, this is your carbon 1, this is your carbon 2. Over here, this is your carbon 1, and this is your carbon 2. Okay, so that there is this on your diene, and this here carbon is this carbon on your diene, and those two carbons on your cyclohexene are these two carbons on your diene. Okay, let's do an example. So we have here 1,3-cyclopentadiene. And we have here a diacid. It's a dicarboxylic acid, but this here is our alkene. So this is our alkene, and this is our diene. So this here attacks that carbon. You form a double bond between those two carbons, and this here attacks that carbon. And again, you form a cyclohexene, don't you? Okay, so this here is our carbon 1, this is our carbon 2. In this structure, this is carbon 1, this is carbon 2. So off of carbon 1, we have a C double bond O OH, and off of carbon 2, we have another C double bond O OH. And that there, no. So to account for this here, so this, I'm going to call this my carbon A. So this here is carbon A, B, C, D, E. Over here on the product, this is carbon B, carbon C, carbon D. So we're not showing carbon E yet. So carbon E is this. This is carbon E. So if you are to draw the 3D representation of that, it will be this double bond, and then C double bond O OH and C double bond O OH. So this is a 2D representation. This is a 3D representation of our product. Okay, the diels-alder reaction is stereospecific. Is stereospecific. So here we have a we have a cis alkene. So therefore our product is going to have the cis cyclohexene. So you're starting with a cis alkene, and you're going to get a cis diels-alder product. So it is stereospecific.